within the Office of Nuclear Safety of DOE. It's a relatively new program, about 4 years old, and began its first funding its first project, I guess, in about a year or 2 years ago. Before that, I guess you came in 2013. He was a senior technical official at AREVA for nuclear regulatory issues in the post-Fukushima epoch. Before that, he was on the staff of Chairman Richard Meserve, the chairman of NRC, which he says was his best gig in his life, his most fun to do. Before that, he was on the faculty at Georgia Tech, and going way back, we discovered both of us had dual degrees from MIT, and his was in mechanical engineering and nuclear engineering. So. Turns out that this program actually does engage universities, but in partnership. It's a small program right now, but it's likely to grow. But they are engaging universities in partnership with laboratories, so I think this sets up fruitful discussions that we could be having after. So, Dr. Levin, take it away.
Thank you. Good afternoon, and thank you all for coming. And thank you for inviting me to make this presentation. I'm going to tell you a little bit today about my program, about how it evolved, what we're doing now, what we're planning to do in the future, and a few other things on the side that DOE is doing in the areas of nuclear safety research. Overview. I'm going to start out by talking a little bit about NRC versus DOE. And the reason I'm going to do this is because I think most of you as nuclear engineering students and faculty are familiar with the way the NRC operates. Heard of it, you know how they're set up, you know a little bit about how the civilian reactor community is regulated by the NRC. You may know that the NRC has a fairly active research program, a pretty large one, to do nuclear safety research, primarily focused on reactors. DOE is not regulated by the NRC, except in a couple of very specific places. We don't deal mainly with reactors. So I want you to get a feel for the difference between NRC safety research focused on reactor safety and DOE safety research focused on other stuff. Talk a little bit about DOE Nuclear Facilities, about the history of the program, what our goals and our plans are, current activities, anticipated activities in the future. Talk a little bit about a new project that's just starting up on nonlinear seismic modeling of nuclear facilities and systems, which is managed within my program. I'm the project manager, but it's not actually part of my program. It's not funded under my program. A little bit about other nuclear safety R&D at DOE that's sponsored by other offices, and what our criteria are for funding and just wrap. Civilian sector, the regulatory process is pretty straightforward. It's fairly easy to understand on a broad basis. The NRC commissioners establish regulatory policy. The NRC staff implements that policy. There are three main regulatory offices: Office of New Reactors, the Office of Nuclear Reactor Regulation, NRR, which does operating reactors, new reactors does new reactors, and NNSS, which has everything else that's not reactor related, medical and industrial uses of radioactive material, except for X-rays, which they don't do, enrichment, nuclear fuel production, waste disposal. And then you have this advisory committee, the ACRS, that sits on the side and provides advice to the commissioners and to the NRC staff. And then, as a service organization within the NRC, you have the Office of Nuclear Regulatory Research, which undertakes research to support the NRC's regulatory programs and to establish the technical bases for the NRC's regulations. Last time I checked, which was a number of years ago, it was about $100 million a year program. They've got about 200 people on the research staff. They do some little bit of research in-house. Most of it is funneled at the contractors, universities, industrial companies, national laboratories, and so forth. And if you go on the NRC website, you can learn all about their research program. So I'm not going to say any more about it today. But most DOE nuclear facilities are not subject to NRC regulation or NRC safety oversight. There are a few exceptions that are specifically included in the legislation that established certain projects. The Yucca Mountain project which is now moribund, for high-level waste disposal, was going to be a DOE facility that would be regulated by the NRC, and the NRC did review their licensing application. And the mixed oxide fuel fabrication facility that's currently being designed and planned for construction in South Carolina will be an NRC regulated facility as well. But most DOE facilities are not subject to NRC regulation oversight. In most cases, DOE program offices, which is the Office of Nuclear Energy, the Office of Science, the Office of Environmental Management, and the National Nuclear Security Administration, which is referred to as a semi-autonomous organization within DOE, and it's under the DOE management structure, but it operates independently of the rest of DOE. That's the defense side, the weapons side of DOE. Those are the organizations that are responsible for both the operation through their contractors and the safety oversight of the facilities. And most of those facilities are not reactors, but they are facilities that handle radioactive material and perform high hazard operations. Again, mostly, many of them, associated in one way or another with the weapons program. But not all. There are some civilian nuclear facilities as well. Within the DOE Safety Construct, my office, which is the Office of Nuclear Safety, which is within the Office of Environment, Health, Safety, and Security, does safety policy with review by senior levels of management, DOE, the Secretary's office, and so forth, and safety guidance. The program offices are actually responsible for direct safety oversight. In other words, they go in and ensure that their contractors' safety programs are operating properly and implementing the policy and guidance that my office has put together. And then, as sort of a quasi-ACRS, but not quite because it operates a little differently, have this organization called the Defense Nuclear Facilities Safety Board, the DNFSB, which provides advice and some formal recommendations to the Secretary of Energy on issues related to the operations and safety of defense-related nuclear facilities that are involved in the civilian side, the strictly defense nuclear facility. The DNFSB was established by Congress, reports to DOE, but it also reports to Congress. So it's a little bit different. It's an independent organization, whereas the ACRS falls under the NRC management umbrella. The DNFSB really operates completely separately from DOE, but there is this linkage between them. And it becomes important for reasons you'll see in just a moment. Together, the four organizations that operate nuclear facilities are responsible for nearly 200 nuclear facilities. We have 4 non-power reactors. The high-flux isotope reactor at Oak Ridge, the advanced test reactor at Idaho National Laboratory. There's another small reactor at Idaho called the neutron radiography reactor. It's a 250 kilowatt reactor that produces neutrons that do radiography on spent fuel assemblies, among other things, and the annular core research reactor at San Diego. The rest of those facilities are not reactors. They either do waste processing, waste handling, or they do radioactive materials handling, either for civilian or defense-related purposes. My program, the Nuclear Safety R&D Program, was established as the DOE corporate Nuclear Safety R&D Program to focus on cross-cutting nuclear safety issues. We support safety oversight responsibilities of my office. But in addition, unlike the NRC, if there's a safety issue that the NRC sees that the industry ought to be addressing because it's related to the operation of the facilities, they can say the industry either can do research on this or the industry can do it themselves, the vendors through EPRI, other organizations. But the NRC doesn't do research to support the industry. They do research to support their own mission. Because we have the responsibility for both operating and doing safety oversight, my program has a dual function in that it also performs research that supports safety operations at our nuclear facilities. Little history. The DNFSB provided a recommendation back in 2004. The NFSB recommendations are numbered by the year and by the number of the recommendation that they've issued. They don't issue that many 2 or 3 a year formal recommendations, a lot of other informal recommendations and suggestions. But this one was one of many recommendations, sub-recommendations were included in this particular one. It said they wanted to ensure continued integration and support of research analysis and testing in nuclear safety technologies. What they did was they took a look and they saw that while there was a little bit of research here and a little research there was no single program that really looked across the DOE complex to try to find significant cross-cutting safety issues that affected the operations of the facilities within the complex. And so DOE made a commitment to establish such a program. And in 2004, they developed an implementation plan. One of the way they respond to these recommendations, one, if they are accepted, is to develop a plan to implement the actions to address the recommendations. And this particular implementation plan said that DOE would establish a program to identify nuclear safety R&D needs and assess if they are met, and to ensure that those needs are budgeted and to share results across the complex. And in 2006, NNSA was assigned as the responsible organization to do this. Well, they sort of diddled around with it for a couple of years and didn't really get very far with it, and because they had other things that they were doing. And since this was more than just NNSA is fine when they want to identify and focus on things that are related to their own operation. They didn't have a whole lot of interest really in doing stuff that wasn't related to their own operation. So in 2011, the program responsibility was kicked back to my office, which was then called the Office of Health, Safety, and Security, HSS. It's now EHSS. And the Office of Nuclear Safety, specifically within EHSS, to develop the corporate NSR&D program covering both civilian and defense nuclear facilities. So our program goals, fairly simple. A focused DOE-wide corporate effort on nuclear safety R&D and coordination across the complex. When I talk about the DOE complex, I'm talking about all the laboratories, the DOE nuclear laboratories that are operated. So you've got Idaho, you've got Lawrence Livermore here, Lawrence Berkeley up the hill, San Diego, Los Alamos, New Mexico, Argonne, Oak Ridge, Brookhaven, Savannah River, and there's also the Pantex facility, which is a weapons assembly facility down in Texas. It's not a national laboratory. So that's what I mean. All of these facilities taken together is what comprises the DOE complex. A way to determine and prioritize the needs and to assess research results and to disseminate those results across the complex. As I said, the program we call the NSR&D Program is managed by the Office of Nuclear Safety. Nuclear safety, we do everything by letter and number codes. The EHSS has the letter code AU. And it has the letter code AU is because our senior manager is an associate undersecretary. That's why it's AU. They didn't want to call it EH because EH has been used before. They didn't want to call it SS for obvious reasons. So they came up with AU because the associate secretary is in charge and everybody seems to be happy with it. So we are AU 30 within the AU organization. So beginning around 2011, and I have to give credit in this respect to my colleague Chris Chavez, who was responsible for doing a lot of this the first couple of years in the program. He started off in 2011 putting all this process together. I came in 2013, was hired to be the program manager, but he did a lot of the early legwork. So Chris put together the initial process that would be used for identifying and prioritizing the nuclear safety R&D needs. He started up an NSR&D website. It's part of the DOE website. And the plan has been to use the Office of Science and Technical Information, OSTI, as our mechanism, as one of our mechanisms to share results. That's in the initial stages because we don't have too many projects that are actually done yet, and so we don't have a whole lot of documentation to submit to OSCA, but we'll be moving in that direction as the program matures. We also, as part of the process, formed a Nuclear Safety R&D Committee, which I am the chairman of as the program manager, with representation from all the nuclear facility operating offices, NNSA, Science, EM, and NE, and they help me pick the projects that we end up sponsoring. There's another group, which is a senior management group, that also is drawn from those offices called the Nuclear Safety Committee. We keep them informed about what we're doing. They provide recommendations if they're needed, but it's generally informal and information and not a management structure there. And our projects are selected to support the policy directives and technical standards development that goes on in my office and improvements to safety and facility operations. The corporate program is not meant to be a replacement for program office funded nuclear safety R&D projects. I'll talk about that towards the end of the presentation. I'll explain what I mean by the differences between those two things. What we do is put out calls for proposals to solicit projects that aren't funded or wouldn't be funded through the program office individual efforts because, again, they're cross-cutting and affect the complex as a whole. So, program activities. As I said, we have the webpage established. The first call for proposals was sent out in 2013. Now, the way we send out calls for proposals, we literally just send them out. Send them out to DOE field offices and to the national laboratories. The reason we don't publish an open call for proposals is because we don't have a lot of funding. There is a lot of budgetary overhead associated if we go outside the national laboratory system. We decided that it was just easier to contract with the national laboratories directly than to go through all that administrative overhead. This doesn't preclude universities being involved because we do encourage the national laboratories to partner with universities where it's appropriate to do so. Obviously, there will be some projects where it'd probably be difficult to do that, but where we can bring universities into the process, we certainly encourage them to do so.
What do the universities do in those 3 projects that you named?
Let's see. Well, the first year we selected 3 projects out of 22 proposals. The Los Alamos project is to develop and manufacture a new design glove box glove for use handling radioactive materials. They've brought students in from, I believe, from the University of New Mexico to help them with the actual design work. Los Alamos has an ergonomist on staff who has worked with them, but the students have been largely responsible for actually doing the design work and modifying the design to meet their goals. The ceramic HEPA filters is being done at Lawrence Livermore. There they have students working on the filter designs and on testing protocols for these filters. I believe they have, I'm trying to remember which universities they have involved. They may have some interaction with UC Davis, and they've got one other university that escapes me right now. And then the in-place filter testing instrument, again, at Los Alamos, they brought students in from the University of New Mexico to work on the design of the filter tester of the software that went along with it. This, that last one, these containers actually have a little filter, high efficiency filter on the cap, so that as they decay radioactively, the gases can escape, don't build up pressure inside the canister, and they wanted to build a device that could assay the contents of the container and the condition of the filter without taking the top off and exposing the people to additional radiation. And that's the one project that has been completed. The report's been completed. The report's been submitted to OSTI. If you are interested, I can provide you information how to get a hold of the report. The second call for proposals was distributed last year in January. We had 32 proposals that were submitted, and we were able to select 4 of them for support. The first year we had about $400,000 for support. This is not big bucks, okay? Usually a lot of people talk about research programs in terms of millions of dollars. We don't have millions of dollars. We have hundreds of thousands of dollars, so we choose very carefully amongst projects that are submitted. We've unfortunately had some very good project proposals that have been submitted that we've had to turn down because their budget exceeds what we have available to fund. And I'm hoping that that will not be the case as the program moves along and we can get additional support, but money is tight right now, unfortunately. And so the second year we had about $650,000, so a little bit more. We were able to support 4 projects. The first one involves the Office of Environmental Management and a subcontract to Mississippi State University to do a study of the performance of aged high-efficiency particulate air filters. DOE has a policy that even if these filters sit on the shelf for a number of years and are never used, at some point they've got to be thrown away because, even if they haven't been used, because they've been sitting around and have aged, and the assumption is they will not perform as they're supposed to. But they're going to find some of these filters, some of these older filters, part of this project, and test them to see whether they can actually meet the performance criteria for newer filters, and if so, they might be able to extend the shelf life, save DOE some money from having to buy additional filters to make up for the ones that they have to throw away. We have a project at Argonne National Laboratory to develop and validate a methodology to model the flow in ventilation systems commonly found in nuclear facilities. I'm talking about small facilities like hot cells. And what happens is that as air flows around inside these hot cells, you have radioactive material entrained in the airflow, and it gets deposited in places. And sometimes it gets deposited in places where you'd like it not to be deposited because it can provide a radioactive source that can give people a dose when they have to do maintenance to those facilities. So they want to model the airflow, model the entrained radionuclide flow, and be able to help design facilities where there is less chance of this stuff plating out where you don't want it. Sandia is looking at the computational capability to substantiate information in one of the DOE handbooks. This handbook has to do with calculation of doses when a radioactive material is released to the atmosphere. And so they're going back and looking at the testing, looking at the models that were developed, and looking to see how good the models are against the data. In a similar vein, Idaho's National Laboratory is working in conjunction with Idaho State University to look at a more risk-oriented, probabilistic type of approach to modeling these kinds of material releases instead of the deterministic sort of approach that is generally used in DOE safety analyses, which might provide a way to reduce the cost of some of the safety systems they have to put in place to address those kinds of problems. The third call for proposals was distributed earlier this year. We had 17 proposals this time and selected another 4. We had about $1 million this year for project support. So we've gone up about 50% a year over 3 years. It's not going to continue going up like that, unfortunately, I don't think. 2 of the projects are continuation of the Sandia and INL projects. They proposed additional work to follow on their initial year, and that Both of those were judged to be worthy of continuation. Sandia is also doing a project on using Melcor to calculate the leak path for radioactive material in nuclear facilities to get from the inside of the facility to the environment. If radioactive material is released because of an accident or some event, it has to work its way through the facility and get out through the ventilation system or cracks in the wall or other means out into the environment. And this this project is going to use Melcor to try to model some of those paths and get a more mechanistic way of looking at this.
Melcor is a fluid mechanics.
Melcor is a reactor severe accident code that has models in it to look at, to be able to model radioactive material moving through structures and out into the environment. So it's not the whole code, it's just that one part of the code, those models. And the last project is another Idaho National Laboratory project to look at mitigation of seismic risk using seismic isolation. DOE facilities are not reactors, but a lot of them have significant inventories of highly radioactive material. They also happen to be built, some of them, in seismically active zones, this being one of them. It would be hard to retrofit an existing facility with seismic isolation, but where new facilities are being contemplated in some of these higher seismic areas, the use of seismic isolation to mitigate the potential for seismic damage to a building might be worthwhile if it could significantly reduce the cost of building the building to seismic codes. These projects really, the way the funding profile is set up, we put out the call for proposals usually very early in the year, make the selection in the middle of the year, and the projects are usually starting the next fiscal year. So these projects will all start in September or are getting started now. Our next call for proposal will be in the next 2 to 3 months. I want to get it out by the beginning of January, or by the middle of January at the latest. That's a goal, not a hard date, but that's what I'm shooting for. We also did our first annual report on DOE Nuclear Safety R&D in 2014. With this report, which is available on the DOE website, on the Nuclear Safety R&D website. It's not put out in paper form right now, it's just an electronic form. It contains a brief description of the history and operation of the program, and then it has a bunch of appendices which discuss individual research projects. There's an appendix for NNSA, there's an appendix for NE, there's an appendix for my program. We didn't get any input this year from science and EM, and I'm hoping that'll change. It gives a flavor of the scope of safety R&D across the complex. Aside from the projects that we fund from proposals, we may undertake, using separate funding within the office, projects that we think are important because something has come up, somebody has raised an issue, somebody's raised a question about something that we think we want to take a crack at. So there have been 3 of these projects so far. One is the development of a technical report on the calculation of atmospheric dispersion at on-site locations for DOE nuclear facilities. This is, you have an accident where you have a release of radioactive material at a site, goes out to the atmosphere, it's dispersed in the atmosphere. There are models that predict how the radioactive material is going to flow downstream from its release point. And the issue here was how do you calculate in the near field what might happen to, say, a worker who's working a few hundred meters away from the release point. And there was a dual purpose to this one. Not only wanted to look at the models for radioactive material releases, but also look at the model for chemical releases and see whether those models were being applied appropriately. And that report is actually done. It's the subject of a circular that was sent out to the DOE complex about addressing how these calculations will be done.
However, the majority of these or all of these reports also available publicly?
Well, they're available publicly because unless they are official use only, OSCE database is searchable publicly, and this one is on the public website. If we have official use only projects, we don't have any yet. If we run into any of those, we might have to withhold the information. We will endeavor to make as much public as we can. The second was development of a technical report on the relationship between nuclear facility safety objectives and accident dose consequences. The NRC and DOE have very similar facility safety objectives. The NRC has a safety goal policy statement that says basically the health consequences of a release of radioactivity from nuclear power operations, from civilian facilities, has to be very, very small. The probability of harm to the public has to be a very small percentage of other risks to which the public is exposed. DOE has a very similar sort of safety goal, and this project looked at the way we model safety against the safety objectives to see whether our modeling and the assumptions we were making were consistent with DOE's safety objectives. This report is still in draft. It's under management review, and I don't know when it's going to be available. So right now, that one's not available to the public. And we're currently developing a technical report on spray release modeling. This occurs when you have a radioactive fluid or some sort of radioactive slurry flowing through a system, usually radioactive waste processing facilities. And those often are flowing through pipes at pressure, several hundred PSI. If you have a breach in the pipe, you can have a spray that releases radioactive material to the environment. And the models for how those sprays disperse from the pipe and then the radioactive material dispersing into the environment were found to be a little primitive and maybe not conservative. And some testing was done at the Pacific Northwest National Laboratory to look at this, and there have been other modeling work that's been performed. And this is really a survey of the state of the art within the DOE complex on this, to be able to show that we understand what's going to happen if such an accident were to occur at one of the facilities. As I said, this one's in preparation, so again, it's not available yet. When it's done and when it's been reviewed appropriately, we hope to have it available for public distribution as well. Near-term objectives. Well, our near-term objectives are to continue to implement the program. We think it's been a success so far as it's gone. 3 years, we've increased funding by a factor of 2.5, and we've gotten some very good feedback from higher levels of management that we're doing good stuff. My management presented some information on the program to Secretary Moniz a few months ago as part of a periodic update, and his response was, "Hey, that looks good. Why don't you have more funding?" And so we're looking at ways to do just that, and we're hoping that we might be able to get as much as another $1 million within the next couple of years. Some of that would be put toward funding additional projects through the call for proposals. Some of them would be to implement other things that I'd like to do with the program, and some of those are listed here. We're going to continue with the proposal solicitation process. We're going to continue to produce the annual report. The second annual report is now being prepared. We're talking about possibly doing a workshop to get, and this would be within the complex, to get people who are working on these projects together and to sort of let everybody know what everybody else is doing, because people tend to get stovepiped at DOE. Sometimes communication can suffer because of that. To improve and enhance the methods that we have for identifying and prioritizing these needs, and to expand outreach with other organizations. And so far, this year, we've already established a collaborative effort with the NRC on that Melcor project, because they're doing similar work at Sandia with the same group using Melcor for fuel fabrication facilities and for possibly fuel reprocessing facilities in preparation for the day if they ever have to license one of them. So we saw a common area of interest there, using Melcor models to be able to calculate the potential accident consequences if release of radioactive material occurs. So we've got that going on. There are other areas which I'm going to be talking to the NRC about possible collaboration. I've made some contacts with the Nuclear Energy Agency, the OECD in Paris. We have some interesting common areas of technical interest that we'd like to get into, and I'm going to try to get a little bit involved with them, and the IAEA. So the international and the domestic community. We also have potential outreach bilateral programs with Japan, Korea, and other countries that we might consider investigating those as well. You need additional money to be able to do a lot of that stuff, so this is where some of that additional funding would go as well. Now, to change gears a little bit and talk about a new project that's been just started within the last 2-3 months. This is being managed under my program, and I'm the project manager, but it's not part of the program because the funding requirements completely outstrip anything that we have available. A proposal was submitted to DOE last year to advance the state-of-the-art in nonlinear seismic analysis through the development of improved models and in support of the development of those models to do new large-scale soil structure interaction experiments. And the objective really is to establish a technical foundation for a significant improvement in the way that seismic risk and hazard evaluations are done for nuclear facilities. Not just at DOE, but for civilian reactors as well. The goal would be to have NRC look at this and to have them adopt these methods to use for civilian reactors as well. You may be aware of seismic risk, particularly after Fukushima, big topic of interest in the nuclear community. So the seismic analysis process that we have now is based on technology that's 20 years old, and it's well beyond time for a step ahead. Older. Yeah, some of the NRC regulations go back to the 1970s. The proposal is for a 5-year project. It's multi-institution, multidisciplinary, seismology, geotechnical analysis, structural mechanics, and a big part of it is going to be designing and building this new experimental facility as well. The players right now, Lawrence Berkeley National Lab, Lawrence Livermore National Lab, UC Davis, and the University of Atarino, which is where the test facility is going to be built. This would be a shake table, a seismic shake table, where they can simulate earthquakes that would have the capacity to carry something on the order of 400 tons of load. It would be a box of soil box, roughly, 500 square feet in cross-section and about 20 feet deep. Be filled with soil with a roughly 1/10 scale building embedded in the soil to look at, shake it, to look at the seismic response to the building and interaction with the soil. So it's a very ambitious project. it's just gotten started up. The reason I'm out here, in fact, was we just had a meeting over at Nevada Reno on Friday to talk about the design of the experimental facility and the overall plan for the project. The first year has been co-funded by my office, the National Nuclear Security Administration, and the Office of Science, and I'm managing it. The funding profile can change as time goes along. That's an internal DOE thing. Since it's not sponsored by one program office, we have to sort of run around looking for money. But this has the Secretary's active interest. In fact, the person who put together the initial team that was looking at this was the Deputy Chief of Staff, the Secretary of Police. So it's at that level that it's being spearheaded. So we're confident we'll be able to pull the money together, and for the full 5 years. And we've also begun discussions with possible collaborators in Japan on this project at the University of Tokyo. We all had a symposium out here back in June on this issue, and some initial discussions were held at that time. I wasn't here, unfortunately. It conflicted with the American Nuclear Society meeting where I had a paper to present, so I wasn't able to come out to that meeting. But this looks to be very promising. The Office of Nuclear Energy has put it in the portfolio of projects that they're going to discuss with the Japanese as part of the overall cooperative program on civilian nuclear technology, and there seems to be pretty good confidence that this will move forward as a collaborative effort. So that's that we're getting visibility not only in the national scene but also in the international scene, which is very promising for us. Yeah.
Just maybe it's just a side thing, but I can understand that the soil structure interaction is very important. But how do you handle the shake table soil interaction? I mean, it's not like when you're putting something directly onto the shake table. You know you can just anchor it down. But how do you transmit the acceleration to the soil?
That's a good question. There's a whole, you need to have all colloquium on that project.
Yeah, I would say that you ought to invite Ian Buckle from University of Nevada Reno and his team to come over and give you a talk about this, because the design, we had a presentation on Friday about designing the shake table, and that's a significant technological challenge in and of itself. But they've been very successful. They have smaller shake tables at UNR already. They have 4 shake tables that I think, 50-ton capacity each. And so they have a lot of experience in doing this and doing it right. And they view it as an addressable issue. You know, they don't think it's.
I would think that the soil would slide back and forth on the shake table as you shook the table.
Well, it's in a box.
Yeah.
So, and the design of the box is what's important there. You know, how it's anchored on the table, how the walls of the box constrain the soil, and that sort of thing. And and in fact, whether the box is going to be rectangular or circular, or, you know, exactly what the design parameters are going to be. That even is a significant part of this project, of the technological challenge of this project, over and above just the size of the modeling part. Now, I told you I was going to get to the issue of the nuclear safety R&D that's sponsored by program offices within DOE, and that's what this slide talks about. The corporate program, my program, is intended to address cross-cutting issues, but the program offices have their own independent research and development programs or projects that look at issues specific to that program office's mission and the safety of their facilities. NNSA has a nuclear safety R&D program, and that's what they call it. So there's a little bit of confusion sometimes between my program and theirs, particularly since you have the same people submitting to both programs. But their process is a little different from mine. And theirs is actually a two-pronged program. They have one half of the program that looks at the safety of their facilities, and the other half of the program looks at weapons safety, so explosive safety. And, you know, the important thing with a nuclear weapon is you want it to work when you want it to work. We hope that that never happens again, right? But you also don't want it to work when it isn't meant to work. So keeping them stored and keeping them safely stored and making sure that environmental insults don't do something you don't want to have happen is an important part of NNSA's program. And that's what the weapons safety part is. The facility safety is actually not too different from my program, but it's focused strictly on NNSA facilities and NNSA safety issues. So we try to let them take the projects that are NNSA specific, and we focus more on the projects that are broader, cross-cutting. The Office of Environmental Management has a technology development demonstration program, which is meant to support their environmental remediation and waste disposition activities. That's kind of an interesting story on this. At one time, it was a very robust program and had a very substantial budget. And over the course of years, it sort of trickled away to almost nothing. There was a task force put together by the Secretary of Energy Advisory Board, which is a group of senior advisors drawn from a wide range of disciplines across the country that advises the Secretary of Energy on DOE issues. And this task force made a strong recommendation for EM to reestablish this program at a substantial funding level, because they saw the need for additional work to be done to support the office's mission. And they are in the process of reestablishing this program at that substantive level. It's not there yet. Part of the holdup, I think, has been the fact that it took an awfully long time to get the new Assistant Secretary for Environmental Management confirmed by the Senate. She's now in office and has been for the last couple of months, and this effort is moving forward, and I'm hoping it moves forward well, because first of all, there are things that they need to be doing to address some of their significant issues, and it would just be a good thing for DOE overall to have this sort of program in place. The Office of Nuclear Energy has a substantial program, as you may well be aware, that supports the development of a wide range of nuclear technologies. They have programs on advanced reactors, on advanced fuel designs, on waste handling, waste disposition from civilian reactors, all sorts of things. They work collaboratively sometimes with the NRC. But the Office of Nuclear Energy is also responsible for the operation of the Idaho National Laboratory. That's their lab. And so they have safety-related research and development projects that relate to the safety of their facilities at INL, as well as safety of civilian facilities. But some of those safety projects, some of the things that they do, for instance, in the area of PRA, are broadly based enough that they would actually be applicable to DOE nuclear facilities as well. So there's a synergism there that we like to try to play on to the extent that we can. I have sort of an active dialogue going on with the Office of Nuclear Energy. Some of these areas, as I said, they're the ones who are actually handling the coordination of the seismic project with the Japanese, because the Civilian Nuclear Technology Cooperation Agreement, bilateral agreement, is actually under their management. So when this was first proposed from Lawrence Berkeley National Lab to me, then I went to them and said, this is something that's worthwhile for you to support, and they finally agreed to do so. And the Office of Science, which operates a number of national laboratories, Pacific Northwest National Lab, Oak Ridge is theirs, Oregon is theirs, Lawrence Berkeley Lab is theirs. They don't have a specific nuclear safety program because a lot of the facilities that they operate, these laboratories are not nuclear. But every once in a while, something comes up that a specific project has to be undertaken. So they do a little bit of nuclear safety related research, but they don't have a specific program to sort of coordinate that research. Now, how do we decide on funding nuclear safety R&D? Because we have such a small budget, we tell people who want to propose to us, you ought to be looking for program office support, you ought to be looking for internal laboratory support, and if that doesn't work, then you can come to us. But one of the main criteria that we use when we evaluate these projects for funding is that they have cross-cutting benefit to multiple program offices, multiple facilities, the potential for cost savings, and to improve the operations and safety of DOE nuclear facilities. So that's really the main basis on which we evaluate the projects that are submitted to us, and if we've done our job right, then the projects that we pick meet that goal. Our continuing objective is to increase funding for the program. As I said, we have the Secretary's attention, so there is some reasonable hope that that will be the case over the coming years, and to increase the number of projects we support. One of the other things that we do here is we ask that people at the national laboratories who are submitting to our program first get an endorsement from the site office that manages the facility. So NNSA has a site office in Los Alamos and Sandia and Livermore and so forth. And the proposals actually come through those offices to us. This ensures that DOE management has had a look at it, and we actually get an endorsement that says, yes, this is useful to our operations. We want to make sure that we're picking projects that are useful to DOE nuclear facility operations. So that's part of the process, and we've been people didn't know what to do with that when we first put that requirement in place, because that was something new. But we found that the proposers and the site offices as well have really gotten involved in this and have provided some very useful input to us. And so that pretty well wraps things up. We're looking forward to expanding the scope of the program and to contacts with other organizations and overall to enhance the value of the program to DOE and to continue to do good research and good publications. I would encourage your faculty to engage with your friends and colleagues at the national laboratories, and if you find that you have an interest in doing something that's relevant to DOE, we're going to continue, until we get more money, we're going to continue to go primarily through the national lab system. As I said, it improves, or it simplifies our contracting process, but we'd really like to see the universities involved, and we've had good experience so far with that. We encourage you to get involved with your national laboratory counterparts. I'd be happy to take any questions.
Quick question. I was talking to congressional staffer a couple of weeks ago. There's a lot of interest in how one could build test reactors or demonstration reactors at lab sites where DOE would license, and with the idea being that DOE might contract with NRC to provide services for some of the safety evaluation, but that ultimately you use the DOE licensing processes, which have potentially greater flexibility. Have you heard anything about some of these thoughts? Not in the civilian reactor arena. I was made aware of some very preliminary discussions that DOE and NASA
have been having about building a possible prototype for a space nuclear reactor, maybe at the Nevada Test Center. And very, very preliminary. I don't have any more details other than what I just said, really. But to be built under DOE's regulatory construct rather than the NRC, so maybe be responsible, like we are for the other non-power reactors. I think you would have to have, the legislation that would appropriate money to those projects would have to specify the regulatory regime under which they were built. I have mixed feelings about the way you just said that. DOE potentially would be more flexible, but I think you might have a hard time on the back end getting the commercial industry to buy into something that wasn't reviewed by the NRC to start with, because it would have to be reviewed by the NRC to get commercialized. Whether there could be some kind of cooperative effort between those two respects, I don't know. It would be an interesting problem to try to address through Boston Nuclear Energy and NRC and us, since we write the rules basically in those areas. I'm not sure they're set up for that sort of thing right now, or if they are, they haven't been exercised in that way for a very long time. I'm not sure I want to say any more than that. Like I said, it's an interesting idea. But nobody has come to us yet with a proposal to do something like that. And frankly, I think it would behoove the NRC, and speaking as an ex-NRC staffer, and one who got very frustrated sometimes with the NRC's internal processes, seem to not move very fast and very fruitfully. And then on the outside too, because when I worked for REVA, I had to deal from the other side to get the NRC to do something that I wanted to have them get done. I think it would be to their benefit to look very closely at the way that they license advanced reactors and develop a regulatory process that would be more accepting of prototypes and first-of-a-kind type reactors that would apply a different regulatory construct to them, leading up to full licensing as a commercial plant. That was sort of the way the AEC operated back in the 50s and 60s when all the prototype plants were built. And maybe there would be a way to get back to something like that. It would be a struggle for the NRC to do that. It would be a lot of work for them, but I think it would be to their benefit to try to address them.
Question here. You were, at the beginning, you were talking about the parsing of the landscape between DOE and NRC in terms of oversight. The one thing that was always, I viewed as this interesting historical curiosity, the Navy Nuclear Propulsion Program tucks up under the DOE budget.
Right.
It's $1 billion plus or something. But as I understand, their regulatory authority devolves from the NRC, not the DOE. Is that right? Or
Not exactly. I don't know the whole story, but the Naval Nuclear Program is basically responsible for their own safety oversight.
Yes, they do their own.
Except the NRC does review their reactor designs as a courtesy, as much as anything else.
Okay.
And the reason they do it is because when the boats are in port, an accident might pose potential public health and safety risks. From that perspective, they look at the design.
Simply the design.
Right.
Okay. As a courtesy.
Yeah,
Okay.
but that's one of the things that when I was working for the Reserve, I got a ride when a nuclear attack sub was they do those reviews, and Dr. Reserve decided that as the chairman of the NRC, he wanted to see one of the subs close and personal. And fortunately, I had a friend over in the Naval Reactors office who I contacted, and he was able to set up the floor because I was the one who set it up. So I got a ride on a nuclear attack sub.
Thank you so much. Let me mention, next week we have actually an old personal friend of mine, Joe Lassiter, who is a senior fellow, Senator John Heinz Professor of Management Practice and Environmental Management Rethinking Nuclear, How Can We Change the World's Cumulative Carbon Emissions Soon Enough. He's a professor at the Harvard Business School. So, thank you once again. For what I think is the first